Okay, so this is 4.2 linear relations, and after the lesson you should be able to graph linear relations both from an equation, from a table of values, or just given a contextual problem. So before we can start, I should say that this lesson is really long, so I'll probably have this in 4 parts, 3 or 4. So just be prepared that there'll be a part 1, part 2, part 3, part 4, or whatever. So anyways, before we can start graphing, we have to review a few concepts. And one of the concepts we need to review is what is this grid in front of us, and that's called a Cartesian plane. A Cartesian plane is made up of, let me just see if I can find my pointer here. Okay, so I'm just going to switch this around so it can point to something. Okay, there we go. So our Cartesian plane is this whole grid, and it has a vertical axis, like a thermometer, and a number line, a horizontal axis. And we usually typically call them x-axis and y-axis, but in this lesson you're going to see that it's going to be time, it can be distance, it can be number of people. So when we don't have a context of what the problem is or the numbers are, then we're just going to call them x or y. Where the two axes intersect is called the origin. We always start all of our points at the origin. Well, the reason why we have a Cartesian plane is because we want to plot points. And every point has a specific name, and it's very specific. So each point has a name, and it's called an ordered pair. So an ordered pair has 5 things. It actually has an x-coordinate. It has to tell me how much I go left and right. It has a y-coordinate. How much do I go up and down? Those 2 numbers are going to be separated by a comma, and it's really important that we actually put the brackets around. If we don't put the brackets around, like say we have 2, 3, and we don't put the brackets around, in French, this actually means 2.3. So we actually have to put the brackets around, otherwise it means something completely different. So I'm just going to erase this. Okay, so where am I here? So what we're going to do is we're going to plot this point. So this tells me I go left 4 and up 5 from the origin. So from the origin, I'm going to go right 4, my apologies, and up 5. And we're going to put a point there. Now instead of writing the coordinate, I'm just going to give it a capital A and say that this is point A. Okay. So the next coordinate that we have, or ordered pair that we have, is -2, -1. So this says I go -2 to the left and 1 down. So from the origin, I'm going to go 2 to the left and 1 down. And I'm going to put a point there. Now once again, instead of having the ordered pair, I'm just going to call that point B, and I'm going to put a B on there. Let me go back. So now we have a -3, 2. So this tells me I go 3 to the left and 2 down, and 2 up. So I go 3 to the left and 2 up. So I'm going to call that point C, and now I want you to try the last 2. So just pause the video and try the last 2. And here are the answers. So 0, -8 is right here. And I'm going to call that point D, because I didn't go left or right, but I did go 8 down. And in this case, I didn't go left or right, but I'm going to go 5 up. I'm going to call that point E, so I don't go left or right, and I need to go 5 up. So point E. Okay. So in lesson 1 in unit 4, we talked about what a relation was, and a relation was relating 2 pieces of data. Well, since we're relating 2 pieces of data, we need to know which one is plotted on the horizontal axis and which one's plotted on the vertical axis. Otherwise, we're going to get different graphs. So there is a rule of thumb that the independent variable is plotted on the x-axis and the dependent one is plotted on the vertical. Now we have words called manipulating and responding. Now those are your science terms. You've done a lot of graphing in science. You learned that as manipulating variable and the responding variable. In math, they're independent and dependent. So to determine which piece of data is which one's which, you have to say it out loud. Ask the question, which variable depends on the other? So I'm going to take you through an example. We want to plot on a graph how far we drive, so the distance, and in an allotted time. So we actually say out loud, does distance depend on time, or does time depend on distance? And so whichever one, they both will make sense, but which one makes more sense? Well, the distance that you travel depends on the time that you travel. So distance would be the dependent variable and the time is the independent variable. So distance, if I was to plot this, time would go on the horizontal and distance would go on the vertical. Okay. So I'm going to stop there as part 1 of our video, and I will reconvene with part 2.